They're asking C0 plus C1, then C1 plus C2, and C2 plus C3. Yes, does it remind you of the theorem of the type? If we could write that theorem first. That theorem is NCR minus 1 plus NCR is equal to N plus 1 CR. Yes, this is a theorem. The proof of this is given in previous video that you can see if you want to see the proof. But here we are going to apply it directly. So NCR minus 1 plus NCR equal to N plus 1 CR. Now, if you look the equation given, you are asked find the value of this. On the left, on this C0 plus C1, C0 can be written as C1 minus 1, and this is C1. So if R is 1 here, in this equation, if you put R is equal to 1, you get this. For R is equal to 2, you get this. For R is equal to 3, you get this. And for R is equal to N, you get this. All right. Means if R is 1, you are getting N plus 1 C1. So this thing is N plus 1 C1. All right. And multiplied by this thing is N plus 1 C2 multiplied by N plus 1 C3. And this will continue. How many times? This is N plus 1 Cn. All right. Now, N plus 1 C1, N plus 1 C2, and so on. How can we write N plus 1 CR in general? See, N plus 1 CR can be written as N plus 1 factorial divided by R factorial, N plus 1 minus R factorial. That we know already. Now, if we open this bracket N plus 1, it is N plus 1 times N factorial. Okay. N plus 1 time. Okay, just one moment. N plus 1 time N of factorial divided by R is R factorial, and the denominator can be written as N plus 1 minus R times N minus R factorial. Now look, N factorial by R N minus R factorial. It can be written as NCR. Means here, if you take away this N plus 1 divided by N plus 1 minus R outside, inside you have NCR. Look, what is left? N factorial divided by R factorial N minus R. This is NCR. So you can say your N plus 1 CR can be written as, this can be written as N plus 1 divided by N plus 1 minus R times NCR. This value over here can be written as N plus 1 divided by N and NCR, NC1, because R is 1, right? Now we want to write this value also. So that would be N plus 1 divided by, in place of R, we are going to write 2. So N plus 1 minus 2 is N minus 1. And time NCR, NC2. Okay. Similarly, the third one you can write, look here. The third one is N plus 1 C3. So you are going to put R is equal to 3 here. So that would be N plus 1 divided by N minus 2, right? R equal to 3 will give you this, and NC3. And look, this is, we want to continue. We want to continue. Time, keep multiplying. So this will go on. The last one was N plus 1 Cn. So for R is equal to N, N plus 1, N minus N is gone, and NC, and you'll get this thing. I mean, this equation here can be written as this equation is it. Now what is this? NC1, NC2, NC3. We are simply saying this C1, C2, C3 also because n is obvious. And if we separate these things, what do we get? N plus 1, how many times? N plus 1 is n times, you see, starting from C1 to Cn. So n plus 1 to power n. In the denominator, what will you have? N minus 1, n times n minus 1 times n minus 2 times, it will continue up to 1. See the last number 1 here. And the numbers there would be NC1 means we can write C1 times C2 times C3 and it'll go up to C and NC1 means C1, C2, C3. Okay. So, well, I think we almost got the answer. So this thing, that product should be equal to 1 plus n to power n divided by n factorial and times C1, C2, C3, and it continues up to Cn. So that would be the product of those values we were asked. So our answer would be this. Okay.